If you sit very still, you can almost convince yourself that you are stationary. The chair beneath you holds your weight. The walls of the room do not tremble. The air is calm. Your senses tell you that you are anchored, fixed in a specific coordinate in space and time. It is a convincing illusion, but it is a lie. In the time it took you to hear that sentence, you have moved. You have traveled 370 miles. By the end of this hour, you will have traversed more than 1,000,000 miles of empty dark. We are not stationary. We are falling. Most of us know the basic mechanics. The Earth spins at 1,000 miles an hour. It orbits the Sun at 67,000. The Sun orbits the center of the galaxy at 500,000. We accept these circles. They are comfortable. A carousel returns to where it started. There is safety in a loop. But the galaxy itself, the Milky Way, is not moving in a circle. It is not orbiting anything. It is sliding. Imagine a crime scene, a body found on the floor of an empty warehouse. No weapon, no footprints, but the body has been dragged. There are skid marks leading into the dark, pointing toward a door that has been nailed shut. That is our situation. The Milky Way, Andromeda, and 50 other galaxies in our neighborhood are being dragged through the universe at 1.3 million miles per hour. We are being pulled by something monstrous, a gravity well so deep and so vast that it defies the standard model of cosmology. For decades, astronomers have tried to identify the culprit. They looked at the direction of our movement, hoping to see a massive cluster of galaxies, a supervoid, or a tear in the fabric of space. They found nothing. Or rather, they found a wall. The direction we are traveling, the source of this terrible gravity, lies directly behind the dust and gas of our own galaxy. We call it the Zone of Avoidance, a blind spot in the sky. We are rushing at 600 kilometers per second toward a ghost. We cannot see it. We can only feel the pull. We are going to follow this river of gravity upstream. We will peel back the layers of dust. We will confront the anomalies that suggest our universe is not the uniform, orderly place we were promised. We are going on a journey to the Great Attractor, and perhaps, if we are brave enough to look, we will see what lies beyond the edge of the map. To understand the mystery, we must go back to a time when the universe felt smaller, the late 1970s. Astronomy was a different game then. It was analog, photographic plates, calculations done by hand. It was the era of the Seven Samurai, not the Ronin of cinema, but a group of astronomers, Bernstein, Davies, Dressler, Faber, Lynden Bell, Terlevich, and Wegener. They were looking for order. The standard model of the universe is built on a simple rule, the Hubble flow. The universe is expanding. Everything is moving away from everything else. If you look at a distant galaxy, it should be retreating. The farther away it is, the faster it runs. This is the general flow. It is democratic. It treats every galaxy the same. But when the Seven Samurai looked at the data, they found a discrepancy, a violation of the rules. They looked at the cosmic microwave background, the afterglow of the Big Bang. This radiation should be uniform, the same temperature everywhere you look, 2.7 Kelvin. But it wasn't. When they measured the temperature of the sky, they found a bruise. One hemisphere of the universe appeared slightly hotter than the other. The opposite side was slightly colder. This wasn't a mistake in the machinery, it was the Doppler effect. You know this sound. When a siren moves toward you, the sound waves are compressed, the pitch goes up. When it moves away, the waves are stretched, the pitch drops, high to low, blue to red. Light behaves the same way. If you move toward a light source, the waves pile up, they turn blue. If you move away, they stretch out, they turn red. The universe was showing us a dipole. We were rushing headlong into the heat. The math was undeniable. The solar system is moving at 370 kilometers per second relative to the cosmic background. But we aren't alone. The samurai realized that the entire local group, Andromeda, Triangulum, the clouds of Magellan, we are all moving together. We call this peculiar velocity. It is a polite scientific term for something deeply unsettling. Peculiar implies a quirk, a localized oddity, but the scale of this motion was anything like local. Imagine a river. The water generally flows downhill. That is the Hubble flow, the expansion. But imagine if in the middle of that river a massive whirlpool began to form. The water would ignore the riverbed. It would be seized by a new current, dragged sideways, swirling toward a central drain. We are in that whirlpool. The 7 samurai calculated the mass required to generate such a pull. To drag a structure as heavy as our galaxy cluster at these speeds, you would need a mass equivalent to tens of thousands of Milky Ways, and it had to be close. They traced the trajectory. They drew a line through the cosmos, following the vector of our speed. They waited to see what monster lay at the end of the line. But the line didn't end in a supercluster. It didn't end in a black hole. It ended in the dust. Nature has a cruel sense of humor. The one place in the entire sky where this massive object could be hiding is the one place we cannot look, the plane of our own galaxy. We live in a flat spiral disk. When we look up at the night sky, we see the beautiful band of the Milky Way. It looks like a stream of milk, but to an astronomer, it is a wall of smog. Gas, dust, and bright stars choke the view. It blocks the light from the universe beyond. We are like a sailor in a crow's nest, trying to spot a distant island, but the mast of our own ship is directly in the way. They calculated the vector again. They checked the instruments. There was no error. We are rushing toward the wall. This created a crisis in the 1980s. The standard model said the universe should be homogeneous, the same everywhere. But here was a flow, a river of galaxies moving toward a concentration of mass that shouldn't exist. If the mass was there, it would break our understanding of how the universe formed. There wasn't enough time since the Big Bang for that much matter to clump together. And yet, we move. The silence of the void is deceptive. It is not empty. It is a tug of war, and for a long time we thought we were losing to something we named the Great Attractor, a name fit for a B-movie monster, but the reality was far colder. It wasn't a monster, it was a place, a basin, a bottomless pit in the fabric of space-time, and we are falling into it. The Zone of Avoidance. It sounds like a psychological diagnosis, a refusal to confront a trauma. In cosmology, it is a refusal of data. It is the 20% of the sky where the Milky Way blinds us. For decades, this zone was a blank space on our maps. Here be dragons. Optical telescopes were useless here. Visible light cannot penetrate the dust. It gets scattered, absorbed. To see behind the curtain, we had to change our eyes. We had to look in the infrared. We had to listen to the radio waves. X-rays and radio waves can punch through the dust. They are the ghosts that can walk through walls. In the late 80s and 90s, we began to peer into the zone. The picture that emerged was chaotic. We found galaxies where there should have been none. We found Dwingolo 1 and Dwingolo 2, massive spiral galaxies hiding just next door, completely invisible to the human eye. But we were looking for the giant, the attractor. We found a suspect, the Norma cluster, a dense knot of galaxies near the center of the flow. It was heavy, it was old, it was in the right place. Astronomers breathed a relief. The mystery seemed solved. We are falling toward the Norma cluster. The math was messy, but it was manageable. We could sleep at night. But the relief was premature. When they weighed the Norma cluster, when they counted the stars and calculated the dark matter, it came up short. It was massive, yes, 1,000 trillion suns, but it wasn't massive enough. Based on our speed, that blistering 600 kilometers per second, the Norma cluster was too light to be the sole cause. It was like blaming a breeze for a hurricane. We weren't falling toward Norma, we were falling through it. The Great Attractor wasn't the destination, it was just a waypoint, a milestone on a highway leading somewhere else.
This is the detective's worst nightmare. You catch the suspect, you interrogate them, and you realize they are just a pawn. The true mastermind is still out there, deeper in the dark. So the search continued. Deeper into the zone of avoidance, further back in time and space. We found the Shapley Supercluster, 650 million light-years away, the most massive concentration of galaxies in the local universe. It is a titan, a structure so vast it makes the Great Attractor look like a pebble. Surely this was it. This was the engine of our destruction, the prime mover. But science is rarely clean. Even with the Shapley Supercluster accounted for, the numbers didn't quite balance. The speed was too high. The direction was slightly off. There is an unsettling concept in physics called the dark flow, a suggestion that the pull isn't coming from a cluster or a void or anything within our horizon. Imagine you are on a raft in the middle of the ocean. You are drifting south. You assume there is a current or a wind pushing you. But what if the ocean itself is tilted? What if the entire fabric of the universe is sliding downhill towards something we can never see? To understand where we are going, we had to stop looking at objects. We had to stop counting galaxies like coins in a jar. We had to start looking at the flow itself, the streamlines, the currents of gravity. In 2014, a team led by Brent Tully proposed a new way to map the universe. They didn't map positions, they mapped velocity. They asked, if we subtract the expansion of the universe, where does the water flow? The result changed everything. It redrew the map of our reality. We discovered that we had been wrong about our address. We used to think we lived in the Virgo Supercluster, a respectable, if modest, neighborhood. But the flow lines showed something else. Virgo is just an appendage, a suburb. We are part of something far grander, a structure of interconnected valleys and ridges of gravity, spanning 500 million light-years. a structure containing 100,000 galaxies. They named it Laniakea, Hawaiian for immeasurable heaven. It is beautiful, it is elegant, and it is terrifying, because a structure this big, it has a center, it has a heart, and all the veins, all the rivers, all the galaxies, including us, are flowing toward it. We are not wandering aimlessly, we are being digested. Part 2 of our journey begins here. We have found the river, we have named the beast. Now we must understand why the universe is broken, why the gravity is winning, and we must confront the empty spaces, because as we are about to discover, it isn't just the heavy things that push us around. The emptiness has a power of its own. Maps are usually static things. They define borders. They draw lines where one nation ends and another begins. But in the cosmos, lines are useless. There are no borders in the vacuum. There is only influence. To understand where we are, we had to stop acting like cartographers and start acting like hydrologists. We had to stop looking at the land and start looking at the water. In 2014, the perspective shifted. A team led by Brent Tully realized that the only way to define a supercluster of galaxies was by its watershed. On Earth, a continental divide determines the fate of a raindrop. If it falls a few inches to the west, it flows into the Pacific. A few inches to the east, it journeys to the Atlantic. The drop doesn't know the destination. It simply obeys the slope of the land. Gravity creates the slope. When the team applied this logic to the positions of thousands of galaxies, the boundaries of our home vanished. We had previously thought the Great Attractor was an external object, something alien calling to us from the dark. But the flow lines revealed a different truth. The attractor isn't outside. It is the downtown core of our own city. We are not falling toward a foreign shore. We are sliding toward the center of our own living room. They redrew the map. They took the Virgo Supercluster, the Great Attractor, the Pavo Indus Cluster, and 100 other disparate groups, and realized they were all limbs of a single organism. They named it Laniakea. In Hawaiian, it means immeasurable heaven. It is a name that carries both beauty and dread. Immeasurable. Laniakea is a basin of attraction. It is a valley in the fabric of space-time so wide that light would take 500 million years to cross it, and every single galaxy inside this boundary, including our own Milky Way, is sliding down the valley walls. We are caught in a gravitational pact. We are bound to neighbors we will never meet. This discovery solved one problem, but it highlighted another. It gave us a sense of scale. It told us that the Great Attractor was simply the focal point of Laniakea, the bottom of the bathtub drain. But it didn't solve the speed. Even with the immense mass of Laniakea accounted for, the math remained stubborn. We are moving too fast. The sheer amount of matter we can see in the attractor isn't enough to generate the velocity we observe. It's like finding a river rushing at whitewater speeds, but the slope of the ground is barely a gentle hill. Something else must be driving the current. This is where the standard model of cosmology begins to creak. We trust gravity. We trust that mass attracts mass. That is the fundamental law. But what if attraction is only half the story? What if we aren't just being pulled? What if we are being pushed? We tend to think of space as a collection of objects, stars, planets, clouds of gas. We ignore the nothing. But the universe is mostly nothing. Huge spherical voids, millions of light years across, where there is almost nothing. No galaxies, no light, just vacuum. For a long time, we thought these voids were passive, neutral, empty stages where nothing happens. We were wrong. Gravity is a game of relativity. If you have a region of space crowded with galaxies, it has high gravity. It pulls. But if you have a region with less matter than the average, an underdense region, it behaves in the opposite way. It doesn't have anti-gravity. Physics doesn't allow that. But the effect is the same. The dense regions pull harder than the empty regions. The net result is that matter flows away from the voids. The void acts like a repeller. It is not that the void is pushing us with a physical hand. It is that the lack of gravity there leaves us exposed to the pull of everything else. The void is expanding, clearing its throat, widening its territory. In 2017, astronomers mapped the flow of galaxies around us and found a cold spot directly behind us, a profound emptiness. They called it the Dipole Repeller. We are trapped in a cosmic pincer movement. In front of us, the Great Attractor and the Shapley Supercluster are pulling with iron chains. Behind us, the Dipole Repeller is shoving us away. This adds a layer of horror to our journey. We are fleeing the emptiness. We are running away from a ghost region of space that refuses to hold us. The universe is clearing out the hollows, sweeping the dust into the corners. We are the dust. And what is waiting for us in the corner? The Shapley Supercluster. If Laniakea is our state, Shapley is the capital of the continent. It is the most massive structure within 1 billion light years. It is a monster, a true gravitational giant that makes the Great Attractor look like a minor anomaly. The Great Attractor was a disguise, a localized density that distracted us. The real flow, the deep river, is heading for Shapley. The combined force of the Dipole Repeller pushing from the rear and the Shapley Supercluster pulling from the front explains our speed. It explains the 600 kilometers per second. The crime is solved. The physics works. But the solution brings no comfort. It only clarifies our insignificance. We are on a raft caught between a geyser and a waterfall. The dynamics are vast, mechanical, and indifferent to our existence. And there is one final unsettling detail. Even Shapley might not be the end. Some measurements suggest that the flow doesn't stop there. Some data hints that Shapley itself and everything in it is drifting towards something even further away. Something beyond the horizon of the observable universe. They call it dark flow. It suggests that our entire universe, everything we can see, everything we have ever mapped, is just a small patch of skin on a much larger animal, and that animal is moving. We are sliding toward an edge we cannot see.
There is a limit to what we can know. It is not a limit of intelligence. It is a limit of light. The universe is 14 billion years old. That means we can only see objects whose light has had time to reach us in those 14 billion years. We live in a bubble of visibility. Outside that bubble, the universe continues, vast, unmapped, and silent. We call this the cosmic horizon. It is the edge of our map.
Standard physics tells us that the universe should be roughly the same inside the bubble as it is outside, uniform, boring. But the movement of our galaxy whispers a different story. In 2008, researchers studying the movement of galaxy clusters found something that shouldn't exist. They found that the river doesn't stop at the Shapley Supercluster. They found evidence that hundreds of galaxy clusters, massive structures containing trillions of stars, are streaming in the same direction at 2 million miles per hour. They are moving toward a specific patch of sky between the constellations of Centaurus and Vela. But when we look there, we see nothing unusual. This suggests that whatever is pulling them, whatever is pulling us, lies beyond the horizon. They call it dark flow. It is a controversial theory. Not everyone accepts it, but if it is true, the implications are chilling. It means that the structure of our universe is being influenced by something we can never see. Imagine sitting in a sealed room with no windows. You believe this room is the entire universe, but suddenly you feel a draft, a cold breeze moving the air. That breeze tells you there is a door, and that door is open, and there is something massive on the other side. Some physicists speculate that this pull comes from a neighboring universe, that in the chaotic first moments of the Big Bang, our bubble of reality rubbed shoulders with another bubble, another space-time. The dark flow could be the gravitational bruise left behind by that collision, a tug from a sibling universe drifting away into the multiverse. It is a humbling thought. We spent decades hunting for the Great Attractor, thinking it was the answer. Then we found Shapley. Now we suspect even Shapley is just a pebble sliding down a mountain we cannot perceive. We are small creatures. We have drawn our maps on the back of a napkin, while the true geography of the cosmos stretches out endlessly in the dark. We want there to be a center. We want there to be a destination, a grand central station where all the trains arrive, but the tracks seem to go on forever. There is a final twist to this investigation, a cruel irony that turns this cosmic noir into a tragedy. We have spent the last 2 hours tracing our velocity. We are rushing toward the Great Attractor. We are sliding toward Shapley. We are part of the Great Laniakea watershed, but we will never get there. While gravity is trying to pull the universe together, something else is pushing it apart. Dark energy. It is the opposite of the Great Attractor. It is a force inherent in empty space, stretching the fabric of the universe, creating more space every second. And it is winning. Gravity is strong over short distances. It will hold the Earth to the Sun. It will hold the Milky Way to Andromeda. We will merge with them in a few billion years. But on the scale of superclusters, gravity is too weak. The space between us and the Great Attractor is expanding faster than we can travel through it. We are running on a treadmill. We are sprinting toward the horizon, but the ground is stretching beneath our feet. In the deep future, Laniakea will dissolve. The river will dry up. The great flow will be broken by the expansion. The Shapley Supercluster will recede from view. Its light will shift to red, then to infrared, then to radio, and finally to silence. It will cross the cosmic horizon and vanish forever. This is the fate of all things in the cosmos: isolation. We are currently living in the golden age of astronomy. We can see the neighbors. We can map the flows. We can see the history of the Big Bang. But billions of years from now, astronomers will look up and see nothing.
The other galaxies will have drifted too far away. The evidence of the Big Bang will have faded. Future civilizations will believe they are alone in a static, eternal island of stars. They will have no way of knowing about the Great Attractor. They will not know about the river of gravity. They will think the universe ends at the edge of their own galaxy. We are privileged. We are the detectives who arrived just before the crime scene was washed away by the rain. We know about the flow. We know we are moving. And even if we never reach the destination, simply knowing the direction is a victory of sorts. We began this journey with a paradox. We feel still, yet we are moving. We traced that movement through the dust of the Milky Way. We found the dipole in the cosmic microwave background. We peered into the zone of avoidance and found the Great Attractor. We realized the attractor was just a valley in the great continent of Laniakea. We realized we were being pushed by the void and pulled by the Shapley giant. It is a lot to hold in the mind. The sheer scale of these forces can make human life feel small. If we are just dust motes caught in a billion-year slide toward a gravitational drain, what does it matter what we do today? But there is another way to look at it. We are the part of the universe that woke up. We are the dust that learned to map the wind. For billions of years, matter flowed blindly, obeying the laws of gravity without question. But here, on this small, wet rock, the matter stood up. It built telescopes. It looked into the zone of avoidance. It asked, where are we going? We may never reach the Great Attractor. The expansion of the universe will likely separate us before we arrive. The mystery of the dark flow may remain unsolved, but that's okay. The destination is not the point. The universe is a river in the night. We cannot see the ocean. We cannot see the source, but we can feel the current. We can feel the pull. We are moving. We are not alone. We are flowing together. And that is enough.